Today we're going to do a little bit of more graphing calculator stuff just to introduce the absolute value functions. And so if you're doing this along on your calculator, go ahead and go to the y equals, and we will go ahead and clear out anything we have in there. The other thing I'd like you to do is if your plot 1 is highlighted up here, arrow up and hit enter to unhighlight it. That may cause a problem with graphing later on. Today, we're just going to look at the basic absolute value function. And on these calculators, the absolute value function is under the math button, which is right under the alpha button. And right arrow to the number menu, and it's the first option, absolute value. So we're just going to look at the absolute value of x, and we are going to graph that absolute value function. And we're going to graph it on the standard window. So the standard window is zoom 6, and that's what the absolute value function looks like. Now a couple of things on the absolute value: both branches are straight lines. The slope of this line is -1. Slope of this part is +1. So there are basically two straight lines that make up the absolute value function. Now, the domain of the absolute value parent function is -infinity to infinity, left to right. And the range is a little bit different than it was for the lines because there is a bottom portion, bottom part of this graph, a bottom limit. So the bottom, and again, range deals with the y-coordinate, so the range going from bottom to top is 0 to infinity. And that range is what's going to be different with these absolute value functions. Now in this first video, we're just going to investigate what adding something to the outside of the absolute value does to the graph. For example, we take the absolute value of x and add 5 to it, and then see what that graph looks like. This next graph will be in red. What it basically does is takes that entire graph and moves it up 5 units. What does subtracting a number do to that? We go to y equals once again, and go down to y sub 3. This will be graphed in black. And we call that the absolute value of x. And then we right arrow to get out of the absolute value. What if we subtract 5 from that and hit graph? Subtracting a number moves it down that many units. And that's basically what adding or subtracting a number does to that absolute value function. So then we're ready to graph these two. So we'll draw our coordinate plane. And we want to give the domain and range of each function. And I'll also show you how to calculate x-intercepts and y-intercepts, which are problems we've done before, just not in this context. So it's going to take that parent function, absolute value of x, where that vertex, or the point on the v, was at 0, 0, and it's going to move it straight down 2 units. So that becomes the point 0, -2. And that's what that looks like. And then there are a couple of x-intercepts we could find. And again, we've talked about this before. In order to find a y-intercept of any graph, plug 0 in for x. In order to find the x-intercepts of any graph, plug in 0 for y. So I'm going to plug in 0 for this y, so 0 is equal to the absolute value of x minus 2. Time to get to your first period class, so I hope you get there. And then we're going to solve this for x. We've done problems like this so far, but a quick review. The first thing you want to do with these problems is get the absolute value piece by itself by adding 2 is equal to the absolute value of x. And then there are 2 numbers that have an absolute value of 2. Remember, absolute value means distance from 0. And there are 2 numbers that are 2 units from 0. One of them is positive 2. The other one is negative 2. That number is 2 units to the left of 0. So there are 2 numbers that satisfy this. They are positive 2 and negative 2. And there are your x-intercepts. And the last thing, given the domain and range. Again, the domain goes from left to right. So the domain is negative infinity to infinity. And then the range, now that's a little bit different. This graph has a bottom. So the y-coordinate at the bottom of this graph is negative 2. And since it includes negative 2, we use a bracket instead of a parenthesis. And the bottom to the top is infinity. So the range of this graph is negative 2 to infinity. And then finally, B. What adding 3 to the outside does is moves it up 3. And we're still going to be opening up. And there's the point 0.03. And we're kind of in luck this time. There are no x-intercepts to find, so we don't have to do any work there. Last thing we need to do is find the domain and range. And to get the domain, left to right is negative infinity to infinity. Again, the range goes bottom to top. This graph does have a bottom on it. It is the point 3. And again, the range deals with the y-coordinates. So 3, top goes to infinity. And that is the domain and range. So that's what adding and subtracting a number outside of that absolute value does to it. It moves it up or down depending upon whether you're adding or subtracting. In the next video, we're going to look at what adding or subtracting a number inside the absolute value of the x does.